Prove using algebra that the sum of two consecutive whole numbers is always an odd number. So to approach a question like these, what you have to do is just think of an integer as n. An integer is just a whole number. So any integer multiplied by 2 would be an even number. For example, if you had 5, 5 times 2 is 10, which is even. If you had 6, 6 times 2 is 12, which is even. So we'll first let n equal an integer, and then 2n would equal an even number. So if 2n is an even number, let's say n was 5, 2n would be 10, then an odd number would just be 1 plus an even number. So 2n plus 1 would be an odd number. And you could also say 2n minus 1 as well. Either way would be fine. So now we'll reread the question. Prove using algebra that the sum of two consecutive whole numbers is always an odd number. So now if n is an integer, n plus 1 would be the next integer. So two consecutive integers would be n and n plus 1. Sum means add them up. So n plus 1 is 2n plus 1. And as we can see from above, 2n plus 1 is an odd number. That's the proof. If 2n is always even for all positive integer values of n, prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So 2n is always even. So two consecutive even numbers will be 2n and 2n plus 2. As there's always a difference of 2 between consecutive even numbers. So we need to prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So 2n squared plus 2n plus 2 squared, that would be 4n squared plus, I'll expand the bracket, this would be 4n squared plus, so 4n squared plus 4n plus 4n plus 4. So it's 4n squared plus 8n plus 4 plus the other 4 squared from before. So that would be 8n squared plus 8n plus 4. So to prove that it's always a multiple of 4, we need to factor 4 out and see what happens. So 4, that would be 4n squared plus 2n plus 1. This is an integer because n squared plus 2n plus 1, if n is an integer, would also be an integer. 4 times an integer would mean it's a multiple of 4, and that's how you'd prove it. Prove that n plus 1 squared minus n minus 1 squared plus 1 is always odd for all positive integer values of n. So we'll start by expanding it all. So this would be n plus 1, n plus 1. This would be n minus 1, n minus 1. Taking that away, then we're adding 1. So this would be n squared plus n plus 1 minus n squared minus n plus 1 with a bracket around it plus 1. So this would be n squared plus 2n plus 1 minus n squared minus 2n plus 1 plus 1. Now this would become minus n squared plus 2n minus 1 due to the minus outside the bracket. So in total we would get n squared plus 2n plus 1 minus n squared plus 2n minus 1. This would be 4n, and we'd carry the plus 1 from there, 4n plus 1. Well, if regardless of what n is, 2n is always even if n is an integer. 4n is even. 4n is always even. Therefore, 4n plus 1 is odd because any even number plus 1 is odd.